Eric Burgess here, and we've been asked to find the weighted mean of the cost. So the difference between a weighted mean and a regular mean is that some of the X points are worth more than other X points. Let's say, for example, you did 5 homework assignments and you got 100 on all of them. 100, 100, 100, 100, 100. But then you took a test, okay? And even though you did the homework, let's just say this test was a lot harder than you expected. You didn't study very hard because you figured, I did the homework, I'm good to go. The professor gave you a really tough test and you only got a 20 on the test. And we're assuming it's out of 100. So this would be like 100%, you got a 20%. If the class is homework centric, let's say the homework's worth 90% of the grade. Well then, who cares how you did on the test? Because these hundreds are worth way more than this 20, right? Because this would only be worth 10% of the grade. Now, normally tests don't work that way, right? Normally, tests are worth like 5% of the grade, homework's worth like 5% of the grade, and tests are worth like 95% of the grade. So despite doing all the homework, it's worth very little because the test was worth way, way, way more. So this was a very important number, had a lot more weight to it. So that's the idea of a weighted average, is that some numbers are more important than others. So traditionally, right, we'd take X bar and we'd say that the mean is equal to the sum of all of the X values divided by the number of X values we call N. Well, in this case, we're going to tack on an extra little bit for a weighted mean. So for a weighted mean, we say that the sum of X, we still want to add all the X values, but we're going to tack on a weight. So when we multiply by this weight, it'll go up or down according to how important it is. So like homework would be multiplied by 0.05, so they would shrink a lot more than like a test, which would be multiplied by 0.95. So they wouldn't shrink very much at all. Divided by, and the weights are what really determines what we want, right? So it can be kind of tricky to determine what X and W should be, what the weights are and what the X values are. And this is actually a really good question here, because I could easily see either the number sold or the cost being a weight or an X value. And it really determines on what we're looking for here. So we're looking for the weighted mean of the cost. So when it comes to weighted mean of the cost, well, we say, how do you know which one's the weights and which one's the X values? Well, we're trying to measure cost. And what that means is, think about how cost works, right? If we sell more, then the cost is going to change. And if we sell less, the cost is going to change. The cost isn't necessarily fixed. It depends on the number sold. And so here, since the cost isn't really fixed, this is going to be our X value, and the number sold is going to be our weight. Now, I know here you're probably thinking the number sold changes all the time, but our cost really depends on how our sales are doing. So the number sold is what's going to get the weight. And I feel like this can be a pretty tricky question to think about sometimes. So sometimes it's helpful to think about the formula too. So if you look at this formula, think about it. If we had the cost as the weight, we would divide at the end by the sum of the costs. So all of these costs would be added up and it would be divided. This would be a very big number. Big. So if we divide that out, and on the top we get, we have some number up here, it's going to give out a smaller number, because when you divide by a big number, you get out a smaller number. So it's going to make our cost look hilariously small. Oh, I'm covering it up. So there's no way this can be the way it is, just looking at how the formula works. So instead, we want, a smaller number down here, a number not necessarily smaller, because that's going to give us a big cost, but we want a number that's going to make more sense. And having this down in the bottom would be kind of a red flag. So if you went ahead and did it the other way, you'd get out some number, and you have to ask yourself, well, if these are my costs, does this seem like a reasonable result that I'm getting out for the average cost, even given the weights? Because maybe the weights could make it blow it up in one direction or the other. So you have to kind of you can use the formula a bit to get some intuition. So anyways, having identified these things, we can go ahead and use the formula. So we have that X bar weighted is equal to, now we have the sum of x times w. So that's going to just be 7 times 430 for the first one. And then the sigma means to add once we've done this. So we did it. So we put add 9 times 360. And then again, the sigma means add 11 times 720. So we're going to get some number up here on the top. We're all out of numbers, so the sigma is all done. Now on the bottom, we have the weights. So the weights are the numbers sold. So we're going to divide by 7 plus 9 plus 11. Right, the sum of the weights. Now here we're going to get a number. Let's check this out. So we turn this on. And we are going to go ahead. I'll use a fraction. So I'm going to use alpha F1. And I'm going to choose the first option, n over d. And we're going to do 7 times 430 plus 9 times 360 plus 11 times 720. And on the bottom, we're going to do 7 plus 9 plus 11. And we get out a decimal, well, in this case, a fraction. So we're going to convert that, go to alpha F1 fraction to decimal. I'm doing this kind of fast because I've done this in so many videos. Like the previous video, you can go check out. I go through the calculator manipulations a lot slower. So, okay, so we get this. This is our number. You could also type it out traditionally and, do the top, do the bottom, and then divide the results. Depends on your calculator. So 524.81. And this is going to be a cost. So looking at this looks like a reasonable cost. And according to all the logic that we did earlier too, this is going to be our answer. But let's say that you did it the other way. And instead of dividing by 7 plus 9 plus 11, let me copy this. You said the weights were the other ones. So we could go ahead and change them to be that. So we could say, oh, that'd be 430 plus 360 plus 720. You're like, these are the weights. It's the cost. But if you do that, you're going to get out, let's convert this to a thing. You're going to get out $9 as the average cost, which seems totally bonkers because your lowest cost here is nowhere near that. So this seems like a very unusual thing here. So this could be a red flag too, that you perhaps did it wrong. Now all the questions, each scenario will be a bit different, but there's some ways to think about it. There's also some ways to sort of tell, hey, maybe something here is a bit screwy. And that is how you do a question like this with a weighted mean. If you have any questions about this, feel free to drop them down in the comments below. If you're a Citrus college student, feel free to stop by online tutoring. We're there to help you out. Subscribe and hit that bell icon, and we'll catch you in the next problem.